Hello, beautiful Passive House nerds. My name is Monty Paulson. I lead the Passive House consulting and certification team at RDH Building Science, and I'm really happy to see you all tonight. It is my privilege to welcome you to the Global Passive House Happy Hour hosted by Passive House Accelerator. This is an inclusive gathering. We welcome people from all stripes of Passive House, all Passive House communities. We welcome people interested in electrification, embodied carboning, climate adaptation, indoor air quality, and of course, in that little task of retrofitting 6 billion buildings in our lifetimes. So please turn on your cameras. We really want to see you. Please turn on your microphones for just a minute and raise a glass with me. A toast to democracy. It's messy, but it works.
Here,
Democracy.
Does it?
Cheers.
Cheers.
Have faith. Okay, now mute your mics. Close that other app you've got open. We have a great show tonight. We have another crazy video involving Sean and helicopters, which is just scary when you think about it. And then a fantastic presentation by Jennifer Hogan of Pretium Engineering on one of North America's first large stepwise EnerPHit projects. Please allow me to introduce my co-host, Prudence Ferreira.
Hey everyone, greetings to you from Philadelphia. I'm Prudence Ferreira and I lead the Passive House practice of Morrison Hirschfield. Thank you to each and every one of you for joining us tonight as we come together for yet another week to learn from each other as a worldwide community that has staying power and strength in our ability to find common ground. As Monty mentioned, tonight we have a video by our very own Sean of Love, Sean St. Amour. A few weeks ago, he was at a secret location as 2 high-performance pods that were constructed by Hewing House were helicoptered into position, and these pods include 5 Passive House principles. Again, please send us your videos. Please, please, you're going to see much more of Sean. And since we're going to be having our prefab summit next week, this method of constructing is a great way to get all of your air barriers installed in a factory setting, no less. Enjoy.
Here at Hewing House's modules, we just landed. You got 2 of them right here. Tech high performance windows, high performance walls, nice and thick, continuous air tightness with the IntelliPlus hiding behind this wall. This one is actually a CLT wall with Mento on the outside, and then the Quata front row is keeping the nice black details all the way around the siding. And you also have hiding up there is a Lunos HRV for continuous fresh air, hitting all the 5 Passive House principles.
Very exciting. Oops. All right. Thank you, Sean. I need to stop sharing here. All right, that was awesome. So we have a special guest. We have Ken Levinson, the Executive Director of North American Passive House Network, has joined us today to share a little bit about a couple of cool events, one that's coming up right away and one that's off into the distance, but exciting. So Ken, why don't you take it away?
Sure, thank you, Zach. for this opportunity, and I will be brief. So as part of IFA's International Passive House Open Days, with events around the world, it's happening this Friday through Sunday, so it's upon us. NAPHN is opening our vault and making available to everyone a lot of owner-related content from our conference earlier this year. So if you didn't attend the conference, shame on you, but it's a good time to catch some great stuff. And the content's all going to be related to ownership of Passive House. We're calling it the Owner's Binge because you only have 3 days. So included are 3 very popular owners roundtable sessions where developers share their Passive House journeys in construction. There are 15 guided building video tours and 5 additional conference sessions that include the owner's perspective in them. The owner's manual, a guidebook for Passive House building owners, and much, much more. So the gates go back up Sunday night. So starting Friday morning, happy binging. And there's lots of great stuff from other allies, Passive House California, in Canada, and projects around the world. But the big news I want to introduce briefly here this evening is that NAPHN is very happy to announce a save the date for our conference next year in 2021. It will be June 10th and 11th, which is a Thursday and Friday. And in these uncertain times, one thing you can count on is a great Passive House conference from NAPHN. And despite of, or maybe because of the insanity going on and going into 2021, it should be the best yet. And that's because we're planning it to be a hybrid conference. We're embracing it. It will be in person in New York City at a reduced capacity for safety and online so that it's totally flexible and everybody who wants to participate can participate wherever they're most comfortable doing so. So there's much more to say, but I'll leave it there for now. Thank you so much. Look forward to seeing you next year there.
Thank you, Ken. That's very exciting. We'll be there. So we're going to go into breakout rooms now for about 5 minutes. This is a chance to introduce yourself to the folks who are in your room and give everybody a little hug. So, because I think some of us need it, and we're going to be okay, but that hug would feel good. So we'll see you in a little bit. All right, it looks like everybody has come back. So I'm going to jump into announcements real quick, and then we'll get into the heart of the matter. So on the Passive House Accelerator website, every Monday we publish a Passive House weekend preview, and where we go through some of the our events at the Accelerator, like today, and the recent podcast from Ken Levinson, who you just saw a few moments ago. It's a great interview between Matthew Cutler-Welsh and Ken. So you to check that out on our the Passive House podcast. We also have a Passive House Prefab Summit that's happening next week, and I'll talk about that a little bit later at the end of the hour. We're urging folks to send their videos, and then of course we've got great events out in the community. So the open days is one, and there are links to open days around the world there. We also have the UK Passive House Conference that's happening every Wednesday, so it just kicked off today, and those sessions are happening every Wednesday throughout the month of November. And then the Passive House Canada Summit is coming up next month. We also have the weekly NAPHN lunchtime special that Ken hosts, and it's a intro to Passive House. You check that out. And Mark Wiley, who is on the call, does a BS Friday every Friday, and this week we'll focus on Bill Hayward and the Hayward score, and we'll also feature Prudence Ferreira. And then of course we've got lots of great educational content being provided, including the one that I want to highlight that's being taught by Monty Paulson, the co-host of the Happy Hour, and that's the pattern language from Passive House that is being presented through MassSave. And so you can see here, and I'll share this in the chat, the link to it. But it starts on November 10th. It's a 4-part series and dives into high performance, low cost lessons for mid-rise buildings. So this is getting rave reviews. So if you this is something you can access around the world, definitely check it out. And with that, I'll hand it off. Thanks.
Thank you, Zach. Yeah, would welcome anybody to join us. The state of Massachusetts, in conjunction with Massachusetts Passive House, is paying for that delivery. So it should be a really fun course. So here's the thing. We talked about this the other night. There are 6 billion buildings on this planet. Together, they emit roughly 1/3 of greenhouse gas emissions. And there is no scenario by which human civilization survives climate change unless we retrofit most of these 6 billion buildings to nearly zero emissions by the middle of the century. To put a point on it, we have to retrofit 6 billion buildings in our lifetimes. The reality, however, is that very few buildings ever do it all at once. You can't stop, everybody can't move out. You know, the nature of a building is has purposes to serve. And so what tends to happen more often is we do things in steps. We do the roof maybe every 20 years. We put a new boiler every 30 years. We do the windows every 40 or 50 years, and so on. And this is why Passive House Institute created the Stepwise EnerPHit program. It allows for a building to be retrofitted on a schedule that can be synced with the normal replacement and renewal cycle. The owner develops a plan, usually with a Passive House consultant, for a model for what the building would have to achieve EnerPHit. And then you break that plan down into steps that make sense for the budget and the renewal cycle of the building. And this allows buildings not to kind of paint themselves into corners and lock themselves into doing some of the high performance things first and then not following through with other pieces. What you're about to see is one of the first large building stepwise projects in North America. And presenting this will be Jennifer Hogan. Jennifer is a certified engineering technologist with more than 13 years of building science experience. Jennifer is a service area leader for energy management, building envelope commissioning, and passive house services. That's a lot at Pretium Engineering, Inc. She's also regional director for the International Institute of Building Enclosure Consultants and is the recipient of several awards from that group, including the Emerging Professional Award. And she's also the recipient of the Ontario Building Council's Rising Star Award. You will see why momentarily. Jennifer?
Thank you. That was quite an introduction. That's awesome. All right, so I have a fair bit of material to cover and obviously a fairly short amount of time to cover it in. So I'm going to jump right in. Hopefully you're all able to see my screen right now. I'm assuming I would have waving hands somewhere if it wasn't showing up. So I am going to jump right in to our agenda for today. So I'm going to give you a quick background on the building at 255 Riverside Drive, which is in Windsor, Ontario. We're going to talk very briefly about why EnerFit and why Stepwise for this particular building. I'll run through the planned Stepwise retrofit sequence that we have for this project. And then I'm going to spend the bulk of my time tonight talking to you a little bit about our phase 2 construction challenges. So some background on the building. This is 255 Riverside Drive. It was constructed in 1975. It's a 20-story building. It has 303 residential units and it is fully occupied. The cladding of this building is TTW brick and it has load-bearing concrete shear walls that are exposed. In about 1985, so roughly 10 years after construction, the vertical metal siding that you can see on the one elevation and at the top of 3 floors of the building was installed. And this was done to address some really early onset deterioration of the TTW brick. Each of the suites in the building does have a cast in place concrete balcony, and those balconies are cantilevered to the structural slab. And the existing windows and balcony doors were single glaze set in aluminum anodized frames. The heating system for the building is electric baseboard heaters, and cooling is actually through wall mounted units that are just plug and play AC units. You can actually see the line of them running up the image that I've shown there. Some units have them installed, others don't. Some units have big, giant, gaping holes where they've maybe stuffed a bit of newspaper. Not the best method for sealing, certainly. The exhaust in the building is ceiling and wall-mounted fans in all of the suite bathrooms and kitchens, and the makeup air is fairly typical for this building typology. It's a continuously operating supply into the corridors. There are boilers on site that help to heat the makeup air and the domestic hot water. So why EnerFit? We'll start with why EnerFit. Well, the owner of the building, Windsor Essex Community Housing Corporation, has already gone through and really tried to capture a lot of the low-hanging fruit in their portfolio of properties. So what that means is they've gone and done little things here and there, like lighting upgrades or other energy efficiency retrofits, or even water saving retrofits that are relatively easy for them to implement. One thing that was a big driver for this project in particular was that a lot of funding is available for energy and greenhouse gas reduction projects in Ontario right now, particularly for social housing buildings. And as long as you can show those savings are going to be in excess of 25%, you typically are eligible for that funding. The client really felt that Passive House was a proven standard. They actually have one new construction project that's also currently underway. And that was something they were really looking for when trying to address deep energy retrofits in their building, and looking at a way to sort of set up this almost as a pilot program so that they can then apply it to many of their other properties. In this case, the building is located at a really desirable and strategic location. You can see in the photograph there, it's on Riverside Drive, it's right on the river. You can look across and see the US from this building. And I can personally attest to the fact that the views of the firework displays that happen over the river are pretty spectacular. The building has really good bones, but a number of the significant components were starting to reach the end of their useful service life. The little table I have there just shows a quick excerpt from one of the building condition assessments we did, and you can see the windows and doors, the makeup air unit, the exterior walls, they were all reaching that point where some sort of major intervention was going to be required. So when the client looked at this and looked at, the amount of work they had to do to the building to retrofit versus what they would have to pay to create a similar building elsewhere, it was quite a bit lower cost, obviously, to do the retrofit at about $69 a square foot versus the new construction, which they anticipated would cost them in the neighborhood of $237 a square foot. So why go stepwise? Well, the stepwise approach allowed the building to pursue certification within their financial constraints. And you can see a quick breakdown of the sort of main 3 phases of actual work at the property. So the balcony doors, the HVAC, and the envelope and insulation work. And you can see there's a number of different things there. So CHC is the client themselves, so what was coming from their budgets for retrofit and renewal. And then each of the other columns is actually a program that they were eligible to receive funding from through the government for repairs and renewals or energy saving projects. So they really were dependent on a number of different programs, which each had a different set of timing for when that funding would be released. So essentially, as was sort of well introduced before this presentation, this stepwise approach allowed them to plan all of these retrofits in a way that made the most sense for the building and also allowed them to work within those funding constraints. The other part of it was, obviously, the building is occupied. It's really just not feasible to do all of it in one shot. And as I'll talk a little bit later, you'll see how even just one aspect of the project had a pretty significant impact on the lives of the people living in the building. So what were the retrofits? And you'll see here, I've got just a quick little shout out to our project team. So obviously projects like this and of this scale don't come together easily and don't come together on any one person's effort. This took a pretty dedicated and significant team of experts to address all the challenges that we're going to talk about today. But the first phase of this project was a sliding patio door replacement. And this actually took place before the project team became involved. The client, knowing that they were planning to pursue either Passive House or EnerPHit in some way, shape, or form, did actually plan the project well, and they included the use of a Passive House certified patio door. But that part of the project was done almost as a pilot in advance of even completing the full EnerPHit feasibility study. The second phase is the mechanical systems installation. That phase of the work actually just achieved substantial completion probably about a couple weeks ago, like mid last month. We're still working on tying up a few deficiencies and completing some testing, but the bulk of the work is finished at this point. Phase 3 and 4 is going to be the building envelope, the walls and windows. So that'll be overcladding and replacement of all the remaining windows at the site. And then there's a number of pieces of future work that are going to take place a little bit further out, typically at the end of the service life. Those were originally planned to be the domestic hot water pipe replacement and insulation of those lines, and elevator upgrades and a roof replacement. Now, because of some changes to the plan, the elevator upgrades are actually underway as we speak. So that project now has moved forward slightly from their original plan. When all is said and done and all of this work is complete based on the PHPP modeling, we're looking at about a 65% savings in total energy for this building. So we're going to talk about construction challenges. This is where some of the interesting things about dealing with an existing building and certainly dealing with an existing building with people living in it come into play. So the first point I'd like to talk about is essentially extensive access being required into the tenant spaces. So we had about 10 key tasks identified, and they're listed on the screen there: demolition, electrical, cutting for fire dampers, corridor ducts, unit ducts, pressure testing, insulation, drywall and bulkheads, and then like millwork, painting, finishes. Each of these required access into the units at some stage in this project. So how did we handle this? How did we sort of manage this process? Well, a detailed matrix was developed identifying each of the units and the 10 tasks, and systems were put in place by the contractor and by the ownership team to make sure that notices were being delivered to those units in advance of entry within accordance of CHC's policies and requirements. Management of the suite accesses, notices delivery, tenant interactions was actually a full-time job for probably at least one staff on the contracting side, as well as one staff on the ownership side. For something like this in the future, out-of-the-box thinking would really be required to try to develop a better system for construction sequencing. The typical sequencing where we had sort of one set of crews go through and maybe complete a floor before moving to the next floor, and then there's maybe a lag before the next crew comes in doing another piece of the work, and a lag before the next crew came in, resulted in what you can see at the bottom there. So we had some units in the example of this task matrix shown where we were accessing their unit in September, October, November, December in 2019, and then again in February 2020. And those aren't even the worst of them. We certainly had some units where we may have accessed them in October or November of last year, and we're still accessing them this summer in order to finish this project. In an ideal world, it would be great if you could enter that unit, do all of the work there until the full scope is completed. But when you start layering in things like balancing and testing requirements into it, that becomes really challenging because unfortunately, those tests have to happen when a larger section of the system for the mechanical equipment is complete. So for example, we can't insulate until we've pressure tested the ductwork. So we couldn't really find a way in this case where we were able to make that flow where we could just enter their unit for a couple of weeks and then be gone and finished with them. Another issue we found early on had to do with space. That was one of the things that we sort of had at our forefront at all times. So I've got two issues here to sort of highlight that. The first is the hallway ceiling clearance requirements. So our design actually had to be down to the millimeter in order to make sure that we were able to meet the Ontario Building Code's requirements for ceiling heights in the corridors. Now, this basically meant because we were installing ductwork through these corridors, we had to design very specific specialized flat bar supports for our ducts. Even just using a standard duct support at the minimum size that it's readily available in was putting us over. And you can see in the sketch, the hand sketch there, we actually had measured out and planned out down to the fraction of a millimeter. And when all was said and done, we had about 5 millimeters of construction tolerance available for this detail. One of the things that we highlighted with something like this in future projects is that we really should have constructed a mock-up right at the outset prior to starting the project. We did do mock-ups once they were mobilized and as we were working through these details, but we had a few conversations with contractors initially, but I think taking it that next step further and actually having a section of this installed at the outset would have been very beneficial to our scheduling once the project started. The other aspect of this was just in general lack of space for mechanical equipment. So in this case, we actually converted 4 units to mechanical rooms to house the ERV units. And we also had a loss of closet space in many of the units to create things like risers to house equipment and for other ductwork. Now, one of the things that sort of worked in our favor in this case was that at one point during feasibility, the client was told that they could potentially need to lose as many as 12 units. So when we put our schematic together and came to them and said we could do it with only losing 4, they felt like we, that was a great deal for them. We may not be so lucky next time. I think if they're expecting 0 and you tell them 4, they may not be quite as amenable to that arrangement, but in our case, it worked in our favor. One thing that's really critical with this, obviously, is to discuss potential space implications with the client at the outset. Because we were taking away closets in some of these units, we had to arrange to purchase freestanding clothes hanging units that were installed and supplied as part of this contract into those units where closets were being lost. That can have a pretty significant impact on someone, particularly in a social housing unit where there's already not a lot of storage space, so it kind of comes at a premium. So it's definitely something to bear in mind at the outset. All right, so I mentioned that we took away some closets for running risers. That created a pretty interesting challenge for us. So in order to create those risers, obviously we had to core through the existing floor slabs. And one of the things that we ran into was a lot of embedded conduits. Now, we had done our due diligence as best as we possibly could at the outset of this project. And the first image you can see there is actually markings that were set up on the floor based on a scan we had done of the slab trying to locate embedded conduits. Now, even at the units where when we completed our scan, it seemed like there were no conduits anywhere near where we were going to be cutting, lo and behold, we start cutting and we hit conduits. About less than 10% of the scan results were actually accurate for us. Now, one of the things that we did consider as a different type of scanning, like something like an X-ray, likely would have been more accurate. However, there's a lot of implications with doing X-ray scanning in occupied buildings. And at the time, it really just didn't, the benefit and cost didn't seem to work out from the client's perspective. So we implemented a couple of things for safety, obviously. We utilized a special piece of drilling equipment that was attached to the core drill. And it actually was designed so that as soon as you were about to come in contact with any live wires, it actually shuts the drill off. This was a huge, huge benefit on this project and made a big difference for us. In hindsight, if we had known how significantly unreliable the scanning would have been, we probably would have structured the project a little bit differently to actually cut the power to the floors and complete the rewiring first around those locations and then complete the core drilling once that section of wiring was disconnected and abandoned. We also ran into a few issues of puncturing existing water pipes in some of the walls. And this was basically where we were penetrating our ducts from the units into the corridors. Now, we did use IR scanners to try to detect any hot water pipes in those locations, but we found that those types of scans don't necessarily locate everything. Things like cold water lines or existing ductwork or other existing out of service conduits don't necessarily show up when you try to scan. So in those locations where our as-built construction drawings were not particularly reliable and the scanning was not really picking up on some of the things that we were finding, we identified those riser locations, and in those places we made the adjustment to shift the penetrations over the doorway. And that basically helped us to ensure by going over the doorway that there wouldn't be any existing services in that space. It did mean reconfiguring some of the bulkheads and ductwork inside the units, but we were able to do that in a way that was still visually appealing. All right, a next challenge that we found, which is somewhat common in existing buildings, is in some of the areas where we had opened up drywall to run our ductwork, some of the existing electrical wiring didn't actually meet the current ESA standards. Now, technically, we weren't touching this wiring. We weren't running any electrical in there. We weren't doing anything to it. It was existing. It was remaining existing. It was completely outside of the scope of our project. Unfortunately, the ESA inspector, when they came by and saw it, identified a couple of things that they felt were safety hazards. Because they felt they're safety hazards, we weren't able to basically sit back on our laurels and say, well, you know, this was how it was built and it met the code of the time. That's not really the case. Obviously, if there's something that's a risk to safety, they would like you to address it. So we ended up having a change order, obviously, on the project, because this is work that we never would have expected to have to complete, where the contractor had to make some adjustments to how the wiring was supported within the ceiling space anywhere that we opened it up. So just be wary, obviously, of defects that are exposed, but outside of your scope of work. That's something in an existing building that can kind of pop up on you that maybe you weren't planning on having to deal with. Next was an issue we ran into with duct air leakage testing through fire dampers. So one thing we found was this building, obviously, we had to use a lot of fire dampers. We were creating essentially new penetrations through floor slabs, through fire separations. We were creating new penetrations through wall fire separations from the unit to the corridor. So obviously that meant lots of fire dampers. One thing that we found when we went to do pressure testing of the duct was that particularly the fire dampers, when we were testing the runs for the vertical riser, because they're basically every 7 or 8 feet, depending on the floor to ceiling height, they were having a pretty significant impact on our testing. And the fire damper manufacturer was not very comfortable at all with us testing these fire dampers via the pressure test the way that we were hoping to. Our solution ended up being that we took the measured air leakage of those duct runs and we subtracted the manufacturer specified leakage through the dampers to basically try to remove whatever the extraneous leakage we were going to be seeing that was occurring as a result of things like the damper arm and some of the other penetrations that are required as part of the fire damper. Going forward and in the future, we would probably try to look to have some discussions with the fire damper manufacturer that's being specified, or even at the shop drawing phase, to sort of more clearly lay out with them what the requirements are going to be for that testing and ensure that the product that they're planning to use for the project is going to be able to meet the testing requirements. So the last one I'll talk about today is tenant interference with the ventilation system. So this is actually a really interesting issue that has just popped up over the last 2 months, I would say. So we have our wonderful system, we've installed our ductwork, the grills are on, the machines are installed, we've started to commission them, and it's time to do air balancing. Well, lo and behold, some of the residents are maybe not so keen on their new ventilation system and maybe don't fully understand the purpose of it or how it works. And what they've done, as you can see in the photographs, is they've gone through and they've actually covered the new vents, the supplies and the extracts, with paper or tape or fabric or other pieces of plastic or cardboard, all kinds of different things. So obviously what happens then when we try to balance the system is we're getting units where we're finding a significant variation from the design CFM to the final actual measured CFM. We made a lot of efforts and worked really hard with the client and the representation on site. We had the contractors enter these units, remove all of the coverings off of the vent, and basically speak with the owners one-on-one or the tenants one-on-one to say, this is why we're doing this. And despite that, many of them advised as the contractor was walking out the door, basically, as soon as you leave, I'm putting it back. So it puts us in a bit of a pickle where, we're trying to get this balancing complete. We're trying to do it for an entire run of floors on an entire wing that's serviced by one mechanical unit. And essentially we can go in the unit 1 minute and 15 minutes later, it's covered up again. So what we had to end up doing was speaking with the certifier about this. And what we agreed upon at this point in time was flagging the units where we're having tenant interference on the reports and making sure that we're including photographs of the blocked vents for submission to the certifier to basically identify the locations where this has been a problem. One thing we're actively working on right now is we're trying to work with the client on completing some additional education for the tenants on the benefits of the system. Some of the feedback received is that they don't want bugs crawling in and they don't want cold air blowing on them. So certainly a little bit more information would be helpful. The other challenge that we found at this building actually is that for many of the people living there, English is not their first language. And so as we're trying to explain to them the purpose or explain to them what we're trying to do, there's a bit of a language barrier there. So one of the things we've talked about is considering offering the materials in multiple languages, or even having representatives from the client side who are fluent in other languages to sort of help offer some additional education sessions for people who are having difficulty sort of understanding what we're trying to communicate to them. So that pretty much brings me to the end of the presentation. I guess at this point, we are going to open it up and take some questions.
Yes, and Sean Pander is the first in the queue. We'll get him started. I've given a few people notice of kind of 1 through 6 of their in the queue. Great presentation, Jennifer. Just take a second to have a sip of your beverage and we'll get all these questions lined
Sounds
up.
good.
Cheers to that. Sean Pender, are you able to ask your questions? And just before you start, thank you to Andrew Peel, who's answered most of them. So Jennifer, you're lucky that he's
Thanks, Andrew.
provided a lot of the answers, but in case you have something to add, we'll let you jump in. So again, Zach's posted your contact info in the chat so people can follow up with other questions or other details. And if Sean doesn't come on, he had two questions. One, and again, I'll just ask the first one just because I thought it was worthwhile. He asked, how did sizing of mechanical work before loads were reduced?
Yeah, so we actually completed all of the modeling and design for the whole project at the same time. So the design for the building envelope work, the windows that we're specifying, all of that was completed in conjunction with the design of the mechanical system. It's only the actual construction part of the project that's going to be phased and stepped in. So hopefully that helps clarify that one.
Yeah, but wouldn't it be grossly oversized? Like, I think the question I had was more, grossly oversizing the system until those loads are dropped. I think, part of the, that was more what I was wrestling with the ventilation system. I was thinking more single family and were the vent duct size big enough before the mechanical retrofit was completed?
Yeah, so basically, because the way this building was designed, there wasn't really a ventilation system per se. We did have exhaust from the units to the exterior, direct exhaust. That's gone away, obviously, as part of this project, right? So we've converted it to a heat exchanger. So all of our ductwork essentially is a new ductwork system. From the perspective of sizing the units and sizing the ductwork, all of those sizing and the equipment sizes are based on the final project. Now, we had to sequence it with the mechanical work happening first, because what we don't want to do is take this building with not a lot of ventilation that's been leaky for probably its entire service life and slap a really tight envelope on it and potentially create more problems than we're solving. So when it comes to doing the stepwise sequencing, it's always best to do the ventilation system first and then install the envelope. You're right, for the first year, and obviously until we put the insulation on the building, we're probably not going to see energy savings, especially not considering there was no system before there is a system now. And in terms of heating and stuff like that, we're expecting that they may still have to rely somewhat on their baseboards, particularly this winter, until that envelope, the insulation is added. And then of course the system will hopefully start to work together and we can sort of scale back the how much we're relying on those supplementary systems right now.
Maybe I can add as well. The makeup air, I mean, it's typical, like pressurize the corridor, hope the air gets into the suites.
Yeah.
That's heated. But how much of that heat is getting into the spaces? So the existing building would have predominantly been reliant on the baseboard heaters. And interestingly, I'm still kind of shocked when I think about this stat. Windsor Essex, the client, half of their operating budget, of all their operating budget, is energy, which is nuts. So clearly those baseboard heaters are doing a heavy load. And so, yeah, we've really scaled back. I mean, just by the ERV itself, that's going to make some difference. Yeah, the baseboard heaters are being kept, and so they're easily able to accommodate extra load between the phases of the building.
Yeah, there's a lot of interesting things about that system as well. The baseboards heaters are actually hooked up to a system that has sort of an automatic override and shut off. They have sensors that are attached to windows and the balcony doors. So if the people within the unit have their baseboard heater turned on and they open a window, it actually will scale back their heat supply through the baseboards until they close their windows. And that system is going to essentially remain in place as a method to help ensure that we're not having, for example, our new ventilation system, which is supplying, warm air. I won't say hot air, but warm air, right? And then we've got, baseboard heaters turn on, windows open, and people plugging in space heaters as well because they're cold, for example. So they have put in place quite a few methods to make sure that hopefully we don't have to rely too much on any of those systems once the full project is complete.
Excellent, everyone. Sean, while you're still there, you had another question that you might as well ask now before we get to the second person.
Yeah, I know dealing with housing projects, selling the loss of rentable units, whether you're trying to get the rent or you're trying to deal with housing affordability and where can we put all these people, like the idea of, proposing, hey, we're going to do this energy project, but you lose units and selling to the tenants that they lose closet space. I can't imagine how you pulled that off. So unless you're like a hypnotist or something.
Well, I mean, I have to give all of the credit for pulling that off essentially to the client, right? They were the ones that were adamant that this is the direction that they want to go with their properties and that they want to be able to do this within not just the new buildings that they're constructing, but within their existing buildings. So, I won't say that the tenant interactions have been easy. I could tell some very interesting stories that maybe will be part of the after hours chat, but definitely, the client gets the kudos for that because they've managed that side of the project for us.
Excellent, great question, Sean. Alana, are you there? And then after Alana, we have Harvey.
Sure, yeah. I actually had almost the same question as Sean regarding the sizing of the mechanical systems, but I'll ask a follow-up question based on that. First of all, I guess first part of the question is wondering what the scheduling is in terms of when is the envelope upgrade happening following the mechanical upgrade? And the second part of that question is, given the height of the building, the fact that it's going to be a lot tighter once it's been, the envelope's been retrofit, in terms of balancing a central ventilation system, stack effect issues, pressurization, and all of that, are you going to have to rebalance or recalibrate, yes, or how is that going to work?
Yeah, that's a great question. So the envelope work is actually scheduled to start construction in the spring. So the final package, we've made a couple tweaks because they had some extra funding come in this year. So we pulled a couple small items out of that package that could be completed this year and did those. So we've made a few adjustments to it, but they're actually planning to tender it within the next couple of months so that it can start as soon as our Canadian winter is finished and the weather will cooperate in the spring. You are 100% correct on the balancing. Once the envelope work is complete, we will have to balance the system again. That is something that we have identified and is part of the plan for that package. Does that answer the questions, hopefully?
Yeah, I was just wondering if there was any challenge associated with that, or it's just a question of, going in and rebalancing it, but it sounds like from your perspective, it's pretty straightforward.
Yeah, rebalancing it, I think, will be a challenge for us no matter what, because who knows how many registers will be blocked by then and how many units we'll have to deal with that fun activity once more. But yeah, I mean, I don't anticipate that we're going to have too many challenges, but again, time will tell.
Yeah,
that'll be the next presentation.
Yeah, I was gonna say, Alana, just wait. We'll get her back in, April or May of next year to do the next phase and all these insights.
Interested in the stack effect issue and stuff, having worked in New York, but yeah, be curious.
Yeah.
I think just on that stack, I mean, because Jennifer obviously didn't have enough time to go into a lot of detail. They're semi-decentralized, however perspective you want to take it. There's each unit, there's 8 ERVs. One ERV sits in one of these suites that were taken away, or there's 2 in each suite, former suite. Why given ERV serves one wing, so that east or west wing, 5 floors up or down. So actually, you don't have that much height difference that one ERV serves.
Mm-hmm. Yeah, that's a great point, Andrew. And you're right. We could probably talk about all the little details for this project for hours on end. But yeah, we basically have a decentralized, semi-centralized system. We also do actually have a couple of floors, specifically the 21st and 8th floor, where the semi-central system is actually not serving those floors. Those floors had existing domestic hot water pipe runs through the corridors, and we pretty much took up, like I said, every millimeter of space there. So on those couple of floors and on the ground floors where we have sort of a different floor plate, different floor plan, we've addressed those units with individual suite ERV units. So those are all completely decentralized.
Great, thank you very much.
No problem.
All right, and now we have Harvey, and Harvey has to rephrase this question to make sure it's phrased properly, Harvey. So you saw the chat there. So Harvey, go ahead and use the right terminology.
I'm not rephrasing. I refuse. I got to get my hands proper. I'm not refusing. Okay. I'm refusing. Okay. I'm not. I'm not.
Go ahead, Harvey. Just say it then.
All right. First of all, fabulous presentation, and I have to say, as a renovator, you guys are quick, because that's a big job, and you guys are going through it really fast, specifically with COVID and with tenants who don't want anybody in. And I wouldn't be surprised you guys ran into a whole bunch of hoarders in there as well. So my question really has nothing to do with that, but it has to do with payback. And I know Kevin's starting to pull his hair out right now. I can see him smiling. But as an ex-banker, that's going to be one of the metrics I would look at.
Yep.
How are they, with all this energy dropping, how are they looking at financing this? I know that the government's putting in, but you can't do this out of just pulling, we're going to do it and we're not going to see a number. But what were they looking at to be able to say there was a return, and how long it's going to take to pay back? And then you're going to start seeing substantial increases in their return on equity.
Yeah. So one of the things that really helped in this case as a driver is that they were going to have to do these projects, not necessarily Passive House or EnerPHit, but they were going to have to do fairly significant, fairly costly projects one way or the other. It was basically like, well, you know, the brick is at this point starting to crumble in many locations. The windows are old, they're leaking. We're going to have to do something about the brick. We're going to have to do something about the windows. So this client's pretty savvy, and they tend to look at their payback, basically saying, well, what's our payback on this extra investment? Because one way or another, we got to keep this building or build something to replace it. In terms of cost, and I'm just kind of going off the top of my head, but I believe that the energy savings at the end of this project is actually going to be about $300,000 a year. So I think the way they look at it was they tried to say, okay, well, we were going to be investing, they were actually going to be investing potentially up to about 22, I'm trying to quote off of a report we did. I believe it was about $22 million over the next 15 to 20 years anyways at this building. We're talking about right now a $14 million investment that theoretically is going to offset some of those future costs in the sort of latter half of this. And so that's really where they started to look at it and say that it made sense for them in this case. I don't think the finances will necessarily work it that way on every project. Certainly, you know, if the only thing you need to do is, you know, replace the roof or replace the windows, going and then replacing everything else is not necessarily going to work in your favor from that perspective. But they didn't ever actually really look at like a set simple payback period for this project. They kind of
how much was the government funding that had to be repaid, or was it forgiven by putting this work into the building? Because then they can look, then they're, you know, $22 million, it drops significantly, because I think you quoted 14 right up front. So I'm just wondering.
Yeah, so most of the funding that they received, the bulk of it is not funding that they have to pay back.
Okay.
It's funding for investment in basically maintaining social housing units. So from that perspective, they weren't required to pay it back. They also did a really good job of like actively seeking out and participating in other funding programs. So the shape and the sharp and the ones where I talked about like the bulk of the money coming from, those were government investments specifically in maintaining those buildings. But they also participated in things like the Union Gas Savings by Design program, where we got to have like a design charrette that was paid for by the utility company, and also provided a couple of smaller incentives. And then they applied for other funding through the Canadian Mortgage and Housing Corporation and stuff like that. So.
Thank you very much. And just quickly, Sean, how many barrels of oil would that savings be?
Well, again, as you're getting prepared for your Passive House tradesperson course, it's 1.5 liters times the savings there. So it's lots of barrels. That's going to be, and how should I just do this one, Harvey? It depends, because we always love that answer in Passive House. All right. Thank you again for that question, Harvey. And in the queue, so it was Peter. And again, we're another local Ontario in here.
Yes. Just as you were penetrating the floor slabs, once they're done, whatever conduit or piping you're putting through, you'd have to close it with fire stop?
Yeah, so basically we installed a fire damper at every floor slab. So the fire damper itself essentially is like you have metal angles that surround it, and then the fire damper acts as that fire seal if there were ever to be a fire.
Okay.
But we also had, sorry?
It's not quite as positive a seal, like it doesn't seal it up entirely as a fire stop would, caulking.
Well, so the way the fire dampers work is they're designed as a fire separation system. And typically most of them don't require a fire caulking around the perimeter. Okay. We do have some other penetrations that we had where we were repairing existing fire stopping that was damaged or deteriorated. We actually had a shocking number of penetrations from original construction or past, projects where we had just like open concrete block holes. We even found one open concrete block hole into an elevator shaft. So that was a lovely surprise. So we did have quite a few fire stopping details that ended up being used to address those, but primarily with the shaft, it was relying on the fire damper assembly itself.
Was it on you with the budget to, once you open up those ceilings and whatever you found as far as deficiencies from previous work, that it became, once you open up, it's on you? Was it out of your budget, or did the client have to pay up for it?
No, so we actually had anticipated, especially with the fire stopping, that there would be some deficiencies that we needed to rectify once we started opening everything up. So we had included a cash allowance for that within the original tender. I believe the work for the most part stayed within that cash allowance. I don't think we had to have an extra change order for anything.
Yeah. And as far as dealing with the inhabitants of the building, I did lighting retrofit project site management. And yeah, I know what you mean.
It's been a journey.
I've been along the same journey. Yeah,
I think the contractor told me he's aged about 20 or 30 years, and it was a young guy who was the site super. I feel like he was in his early 20s, and he's like losing his hair, and he's earned his stripes on this one, I think.
And the covering over of the vents as you put them in. Yep, I know all about it. And new LED lighting suddenly went missing.
Yeah, we did have we had construction light bulbs removed, that kind of stuff. Yep. Temporary lighting. Yeah.
Good work. Yeah, I know the kind of building. I lived in one like that in Toronto. So yeah, drafty and nasty. The balcony, is that going to be separated? Is it going to be rebuilt, torn away?
Oh, interestingly enough, actually, the client is adamant that we cannot remove the balconies at this building. And part of it actually goes to that view I was talking about over the river. So we've designed some details for the building envelope to try to insulate those as best as we can. And Andrew's team actually has done all the modeling basically to make sure that we're still hitting our comfort and hygiene criteria and stuff like that. So we've managed to make it work. We'll see how it goes once the rubber actually hits the road on that one in the spring.
Good luck. Good project. Continue.
Thanks, Peter. We'll dive into the envelope in the after hour, just because I know lots of people have asked about it. So Jennifer, just take a second to again relax, and we're going to turn over to Zach to wrap things up for the happy hour before we dive into the next phase.
Yeah,
awesome,
thank you. Yeah, thank you, Jennifer. This is fantastic, and thank you, Sean. So I want to announce the next happy hour as well as a couple of other events. But first, as is our wont, we want to thank our sponsors who make everything that we do at the Accelerator possible. So our founding sponsors are Baxt Ingui Architects, Mitsubishi Electric Train HVAC US, RDH Building Science, StoCorp, and Zola Windows. Our stakeholder partner is NYSERDA, or the New York State Energy and Research Development Authority. And our patron sponsors are Morrison Hershfield, 475 High Performance Building Supply, and Partel. So please support our sponsors. We're really happy for their funding to make this stuff work. So next week we have something completely different from this fantastic presentation, but perhaps apropos given the election season that we're in. So this is all about, this is a project by Maren Longhurst of Rodell Architects in Spokane, Washington. And this is a firm that does all passive house in their practice in the middle of red country. So she's going to be talking about Fernon Lake House. It should be a great presentation. This is a FIA certified project. And then on Thursday of next week, we'll be holding our first Passive House Prefab Summit. And this will be on Thursday, November 12th. And it's going to include 6 different prefab manufacturers from North America, 3 from the East Coast, 3 from the West Coast. We're bringing the hive mind together to talk about passive house and prefab. And our very own Sean St. Amour will be the moderator for this. We just had a great planning session with Sean and Mary James, of the Accelerator, who is helping to organize it. It's going to be great. So don't miss that. And I'll share a link to registration. I think we've already done that once, but I'll do it again. And then finally, on the 17th, Tuesday, the 17th, we're going to have our first Passive House Construction Tech Tuesday, this same time. So 4 o'clock Pacific time, 7 o'clock Eastern time, 11 o'clock Melbourne time, at 11 a.m. We'll have Sean and Mark Wiley and Kevin Brennan and other special guests coming together to talk about construction tech and passive house. So don't miss that as well. Thank you.
Thank you, Zach. What time is the Prefab Summit?
Oh, let me bring it up. That's a good question. I should know that off the top of my head.
4 p.m. Pacific time. 4 p.m. Pacific.
4 p.m. Pacific.
So that's the tech Tuesday. Yeah.
Okay, so I can find it.
So yep, it's coming.
That is also 4 p.m. is.
Yeah.
Oh yeah, that's right.
I'm
You're
looking
right.
at
I'm
it.
sorry, Susan.
No worries.
Absolutely.
I got it on my screen. Am I losing my
Thank you.
mind?
And Mary, I heard your voice.
Okay, well, that's going to be really exciting. I know we're all following that. Hey, so much thanks for this presentation, Jennifer. This was absolutely fantastic. Special shout out to Andrew Peel, who's been here answering questions and is such a fantastic resource, especially on really pioneering projects like this, as he has been for many, many, many years. Thanks, Sean, for yet another great video. Challenge to everybody else to kind of make some videos and share your projects with us. Thanks to everybody. Prudence?
Prudence is at the FIAS board meeting.
Very important FIAS meeting.
Yep.
Hey, you know what I want to add? I have heard rumors that FIAS is also thinking about a stepwise program at some point too. So it'll be interesting to see where all that goes. Anyway, thanks to everyone. Fantastic. We'll let Sean sail you into the after hour.